So, good morning, students. Today I am going to show you some more graph on Python Panda. We are ending our frequency polygon. Frequency polygon, and I will show you today also the box graph that you have in your syllabus. Frequency polygon is today I will end today, and box graph I am going to show you. So let us see how we can implement it and how we can do it. Now see here, this is a frequency polygon. In this particular frequency polygon, what we have imported matplotlib.pyplot as plt. So as we have imported the matplotlib.pyplot as plt, now here I have given some values. See here, x equals to some values has been given randomly, different types of values has been given here. Then what it has been given in this particular case, say a comma beans comma c plt dot hist. Okay, so plt dot, that means a one variable beans, and c is taking plt dot hist, that what x comma beans equals to 7 hist type steps. Okay, then L equals to list beans. Those beans I have called here in the list. Then L equals to insert 0 comma 0, the particular point that you will going to insert. L dot insert length of beans plus 1, and that the range I have taken, and beans length of beans minus 1. So this is the range, that means starting point, and the ending point has been given, the mid point. Now because here we have to create the histogram with a line graph and with a bar graph, frequency polygon with histogram and the line graph. So here you see, for I in range, len L minus 1. Okay, so ELE equals to 1 I minus 1 I plus 1, isn't it? So I plus 1, that divided by 2. So L that we are taking the mid dot append ELE. So we are taking the mid value in this way. So x equals to list A. X insert 0 comma 0, x insert length a, then 1 comma 0, plt dot plot mid comma x geo dash dash, 2 dash has been given here. Okay, so plt dot x level, the intervals of the beans, that x level I have given, then y level name has been given, title has been given, and plt dot show. So this is the thing what you can see here in this particular graph, in this particular area, that we have our work, and we are making this particular work to be implemented. That means what we have done, see here, at first we have taken the matplotlib.pyplot. So when we have taken the matplotlib.pyplot, in this particular matplotlib.pyplot, I have taken some range of values, isn't it? So this is the range of values that I have taken it here, and when those range of values has been taken, there we can find here that what has been given, a means one variable has been taken for it, beans and c. So those are the sections, different 3 sections has been allocated for here. Okay, so in that what we have stored, see plt dot hist, there we have stored here plt dot hist. So where we are storing the plt dot hist, what x comma the value of x will going to come, those the values, then beans is what 7, and their his type is step. Okay, so this a where we have called, see here, a we have called in the middle where x equals to list a, isn't it? So there we have called this a, and we are working with it. So that means this is the value what we are having, and what we are calling here, we can find it. This is the way the thing will going to be constructed, thing will going to work. So when thing is working in this way and thing is making in this way, there we find it that what we have done, that L equals to list beans. That means we are taking the total list of the particular beans, the beans what is 7. Okay, so there we find it that we have here L dot insert. Okay, L dot insert. So L dot insert means what, that we are having 0 comma 0. So this the 0 comma 0 we are having here, and L dot insert is what, len beans. Okay, so length of the beans, what will be the length of the beans, that will be going to be taken here. Now here what he has given plus 1, and next what have been given bean length of beans minus 1. So plus 1 to minus 1, this the whole range has been taken from here. Okay, so beans is 7, that means plus 1 means what, total what is the length is coming, based on that with 1 will be added, and what is the length, based on that 1 will be deducted. So this is how we can find it, this is how we can see it, that when you are constructing this particular structures, when we are making this particular structure, we have this particular pattern and we have this particular scenario to be worked with. So when we are finding those particular scenario or those particular pattern to be worked with, then what we have, that mid equals to, then we open the bracket and we close the bracket, isn't it? So as we open the bracket and close the bracket, that means here you can find that for I in range, we are taking the range of I. What is the range of I? The range of I is what, there is a length L, that L minus 1, isn't it? Length of L, what will be the length of L? That is L is what? L is the list of beans, isn't it? So we have given the L means what, list of beans, therefore those list of beans will going to come as we are having those particular pattern or those particular area, in this particular area, in this particular pattern that we are constructing it, and we are having it here, we can make the particular structures, and we can work on this particular pattern or particular structures. So this is the particular pattern or particular structures that we are constructing, and this is the particular pattern or structures that we are having it here. This is the way, or this is the part that we find it, that we will going to construct this pattern of scenario, and this pattern of implementations. So as we are having these implementations, where we are finding that we have those implementations that we will going to find from the structures that we are constructing it here. Okay, so this is the way, or this is the pattern that we can find, that how we will work on this particular pattern, and how we can implement this particular pattern. So this, the implementation is very important, that how we are implementing. Now you see what I have taken, mid, the mid value, blank area. Now in this mid value, what it will going to pass for I in range, what is the range that you will going to have it, that those the range we can find it, that len L minus 1. So len L minus 1 that we are finding is ELE, what we have, that Li plus Li plus 1, so that total will be divided by 2, isn't it? So this is the thing, then mid dot appearance, this is the function I am calling here. With the help of this function, what we will going to get, this is the particular value of ELE, that means the middle point value, we will going to append it from there. Okay, so this the append function has been called here, and we are getting it. So x list is A, and x insert is 0, 0. So this is how we can find it, that we have this particular pattern, we are using those particular pattern, isn't it? So this is the way, this is the pattern that we can find it, that as we are constructing on, as we are having it, we are going to fetch, or we are going to make it in such a way, or in such a form that they are being inserted and they are being worked in this particular pattern, or in this particular area. Okay, so those the areas, those the pattern that we are having, those the patterns that we are making it. So we can find it, that how they will going to construct, how we will going to make it. Now what we have given, plt dot plot mid x, mid comma x, that means we are calling here, what we are calling here, the x. Now what we have called here, say go dash dash, go dash dash means we want to give that line in a dash form. Okay, so in a dash dash form, only 2 dash you will give, don't give by default 3 dash or 4 dash, it will not work. Okay, so you will give here only 2 dash here, based on that then those the namings like x level naming, y level naming, title naming and plt dot show. So this is how what you can see, this is how what you can find it, that how we can make this particular pattern, how you can work on this particular structures and how you can see it. Now let us see what is the output that you will going to get from here. Now see here in this one what you can find, see this is a plan of histogram and this is what the frequency polygon and the point, each of the point a midpoint it has taken, and there with a dotted line the thing has been designed and graph. So this is how you can design a frequency polygon with the help of an histogram and line graph, isn't it? So this is the particular part, this is the particular implementation that we can find, that how we can use it and how we can work on it. Okay, so as we are working on it, as we are finding it, we can see here that each of this particular part, each of this particular data type we will going to implement, and we can make those data type and we can work with those particular data type. Fine. So this is the sections, this is the point that we are working, and we are making it to be worked, and we will going to get this. Now let us see what is the next graph that we have with us. Now see here the next program. Next program is what? Next program is a that we are doing a simple box graph, isn't it? Box graph is also pattern of a histogram. So here what you can find it, that I have used here import matplotlib.pyplot.splt. Other thing I don't require here, so I haven't called other numpy or pandas, isn't it? Those the things I haven't called here. So as I haven't called here, we can find this particular thing that we can execute. So as we can find those things is executing, then what we have, so in the list one I have given some values, isn't it? So list one I have given some values, some frequent values has been given. In the list 2 also I have given some values. So I have given some value in the list 2, then I have given a data. In the data what I have given here, in the data I have mentioned here the list 1 and list 2. Now what I have written here, see plt.boxplot data. Okay, plt.boxplot data and plt.show. Now in this particular area, in this particular part, that we have this particular structure, designing and all will be more or less same in all the graph that I have shown to you, and this is the last section of our graph, that is a box graph or hanging graph also it can be said as. So box graph or hanging graph, as we are using this particular box graph or hanging graph, we can find it that how we are constructing it. So what has been taken, a first thing that we have called here is a matplotlib, because matplotlib is a library function without which we cannot design a graph. This is the library, important, very important library function for what? For our designing of the graph. So as we are designing the graph, as we are finding that we are designing this particular graph, we can find it here that those things will going to be implemented. So as we are implementing those, as we are finding those particular thing, then what we have a pyplot as plt. So pyplot system that we are constructing, pyplot system that we are having, so each of this pyplot system we are constructing here in the part of what? In the part of this particular structures that we have here for the declaration, isn't it? So matplotlib, as we have called the matplotlib.pyplot, so in this pyplot we are constructing the structures and we are having the structures to be implemented with. So pyplot as plt means in this particular pyplot system we are giving the values and we are having the values to be implemented in a certain order on a certain way. Now as we are calling this particular pyplot, as we are using those particular pyplot, what we find here, that list, first list series I have given it here. In this first list series we find it, there are the values are there been implemented. Okay, so those the values are they are being implemented. Now list 2 is what? See here in the list 2 there is one mode series has been given. So there are the 2 series that we have given it here. So in this particular 2 series what we find it here, that see the data how we have given. isn't it? Like 42, 76, 34, 63, 56, 82, 87, 55, 64, 87, 95. So all these things, that means within a different range of the values from 14. What is the lowest limit there? 14. Okay, and highest limit what we can find it here, 95. And see here in the list 2, what is our lowest limit? Lowest limit is that we have here what that 34. Okay, 23 is the lowest limit, and the highest 18 is your lowest limit, and the highest limit that you are having it here is in the case of 70s. Okay, in the field of 70s, that means 76 is the highest limit. So those are the ranges. So I didn't you see this thing, the ranges that has been declared, it is not crossing the particular declaration format, it is not crossing the declaration part. So as it is not crossing the declaration format and declaration part, we can find it here that we have this particular structure, and when we have this particular structure, so each of this particular structure we can find it here, each of this particular part that we can find it here, that we are organizing them in a certain way. Okay, we are implementing them in a certain way. So those the certain pattern of implementation, those the certain type of implementation that we are doing, and we are working on it, how we can find it, and the work can be done and we can complete it. Okay, so what I have called here, I have called here data, what the value to be given, list 1 and list 2, because you know that we have two axes, x axis and y axis. For x axis and y axis we have to take the value. Lastly, in the frequency polygon and data frame, with a data frame and polygon, when we combined, and I have shown you there you have seen it, that when I have declared total data frame to be worked with, it has taken the value from the two structures or the two number series what is there, except the other the character field is not been accepted, because we know based on character field what the graph can be drawn, isn't it? It should be on a number field. So based on this number field, obviously we will going to design the graph, and as we are designing the graph based on the number field, that means we have to take the number field. Data frame, you have seen data frame has been done there, and with the data frame it has taken the values from the particular data frame, and using those values of the data frame, it has created the thing. So this is the thing what we can find, this is the part what we can find, that we can do it, and we can work on it. Okay, so as we are doing the particular pattern, as we are doing this particular structures, so each of this particular pattern, each of these particular structures that we are doing, and we are making and we are executing, we are having those particular format, and we are making those particular format to be implemented in a different way or in a different manner, that we have the structures that we can build up the structures. Okay, so there you have seen it, there you have find it, that total data frame I have constructed, and from the data frame I have given a command to extract the total, use the total data frame. It has taken the value and it has plotted it as per its own pattern or way that we have find the frequency polygon has been done, isn't it? So other way of frequency polygon also I have shown you just now in this previous program. So different way we can design the frequency polygon. Now let us see, this is the floating box or floating graph. Let us see what is the output of it. So you see here, what is that? See, this is a floating graph, or we can say it as a box graph. Okay, floating graph or box graph. So based on those values, the values that we have taken, see here from the range, they has taken the different range 1 and 2, list 1 and list 2, that is based on the list 1 and list 2, what are the values there, which is the point it has been taken, that where it has the major dividing point of the box. So those the things what we can find it, that it will going to construct in this way. Okay, so this is what your floating graph or the floating point that we find it that we have here, and we see it there that those the particular thing that is been working and we are having it. So we can find it this way, we can construct it, the floating graph. So I have completed your those two sections, that one is your floating graph or the box graph, and one is what the particular frequency polygon. Okay, so today I am ending my today's session here. Thank you all.